Okay, this is the 4-3 notes for Algebra 2. We're looking at dividing polynomials. This is pages 391 to 399. Assignment pages is 400 to 405. Problems 1 through 10, 13, 14, 15, 18, 19, and 20, excluding number 8. Okay, so there's a lot of pieces to this. There's two very specific ways that you can do dividing polynomials. Uh, to be honest with you, I find one of them much easier than the other, but whichever one works better for you, go ahead and use it. There is one very important piece to this. It's understanding um, what you're looking at when you're doing dividing polynomials. The whole point of a polynomial is to find a result when you plug in a number. So one of the ways that we can do it is called synthetic substitution, where you take the -2 and we plug it in to the x's in the equation. So it becomes 4 times -2 to the third, where x becomes -2. 3 times -2 to the second, 2 times -2, and then 1, and then we can work through PEMDAS all the way down, and we find out that negative p to the negative of -2 is -23. If we were to put that equation into a calculator and then use table, look up -2 on the x, you would get -23 on the y. So that leads us to something called synthetic substitution or synthetic division. Um, I personally find this to be easiest, but it does take a little bit of working through so you can figure it out. First step is to figure out what are you dividing by. Well, whatever the p number is that you would have plugged in up above, that's going to be what we're actually going to be synthetically substituting and dividing and multiplying, or multiplying and adding with. The numbers that are the coefficients of our equation are going to be written across. Now, it's really important that we have a representation for every exponent that there is, um, including x to the 0. So counting backwards, 3, 2, 1, 0, we have to have a number for each one. And if there's one missing, you fill in a 0. So now what we do is the process is this. You drop down your 4, the first number, then you multiply times -2, and that goes into the below the second number. Then the next step is we add the second two numbers. So 3 plus -8 gives us -5. The next step is we're going to repeat the multiplication step. So we do -2 times the -5, and we get a positive 10. Then you add 2 plus 10 to get 12. And then the final step is -2 times 12 to get -24. And then add 1 plus -24 to get -23, which gives us p of -2 is -23. This is called the remainder. So the answer when you get in that last spot is going to be where that x value is on the graph. So it's kind of a quick little multiply, add, multiply, add, multiply, add, and you got your where that particular would be in without ever actually plugging it into the original function or that we had started out with. So that's one way of doing it. That leads us into different ways that you can actually divide polynomials. One of them is called long division. And this is reminiscent of when you were back in elementary school where you did 277 divided by 12. You'd say, how many times does 12 go into 27? Well, that would be 2 times. 2 times 12 is 24. Now we subtract and we get 3 left over. We bring down our 7. How many times does 12 go into 37? That would be 3. That's 36. We subtract, and then we get a remainder. And we would write our answer as what we divided by, the fraction 277 over 12, is 23, our quotient, plus 1 over 12. So we're going to do basically the same idea with polynomials. So we have our dividend, uh, which is what we're trying to divide into, divided by our divisor, which is what we're dividing by. But this is a little bit more complicated than what we did back in elementary school. So the idea here is you're going to ask yourself, how much do I have to multiply this by to get that? That's the only part you're going to look at first. So So we're trying to figure out what we have to multiply times x squared, so we get 4x cubed. So we have a 1 in front of the x squared, so what times 1 is 4? Well, that gives us 4. And then how many x's are needed? Well, I need 3, I have 2, so I need to multiply by at least 1. So that tells us that we're going to be multiplying by 4x. That's how we figure that out. Then the next step is to take that 4x and multiply it times each of the pieces, like you would do on the triple rainbow. So 4x times x squared is 4x cubed. 4x times 3x is 12x squared. 4x times 1 is positive 4x. And now the next step is we have to subtract. Well, when we subtract something, we change all the signs of everything that we saw. So that becomes 4 minus 4, 2 minus 12, which is negative 10x squared, and 3 minus 4, which is negative x. Then we bring down our plus of 5, and now we ask the next question. What times x squared do I need to multiply to get negative 10x squared? Well, I need to multiply by negative 10. So that's what's going to be multiplied by. Then we take that and multiply it times each piece. So negative 10x squared, negative 30x, and negative 10. Now we change all our signs and add down. That goes away. That becomes 29x, and that becomes plus 15. So when we're done, we end up with 4x minus 10 plus 29x plus 15 over what we divided by. So you're not done until you've written not only what your quotient, but also your remainder over the divisor. Okay, so doing dividing of polynomials can get very messy. It is very long. You do have to remember to add in a 0 if there is a missing exponent. So 4, 5, 3, we were missing 2. We have to add in 0, 1, none. So I worked this one all the way out. And again, you are going to ask yourself, what times x squared do I have to do to get 6x to the 4th? Well, that ends up being 6x squared. Then you would change your signs and add down and repeat the process. I've done one more example. So again, what times 3x squared do I need to get 15x to the 3rd? Well, I need 5x. Bring that down and multiply across, change my sign, add. What times 3x squared do I need for negative 30x squared? Well, that'd be negative 10. And then we add down and we write our quotient. So that's kind of messy. It can get really kind of complicated. So there's a second way that we can do it. It's called synthetic division. Synthetic division is what we started with, which was where we took what we're dividing by, which is what we're subtracting part here, all of the the coefficients from our problem, and then we're going to follow the process we talked about before. So we're going to do a couple of examples like that, working through this. So first step is we have to figure out what we're going to divide by. What goes in the box? The way we find that is we set what we're dividing by equal to 0 and solve for x, which means we're going to subtract 3 and we get x is negative 3. That's what goes inside our box. Okay, that would be that's where we're going to be looking on the graph. If we were trying to figure out what what was going on in the graph, we would go x is negative 3. Now we're going to find out what the y is, and we would plug negative 3 in, and that would give us our y. Well, when we do this, we're actually looking for all the factors. So we're trying to figure out, is this a 0 for one thing? Does it cross the x-axis at that point? And if it does, then that lets us keep breaking it down until we've got all of the zeros that could possibly be. So we're going to take the coefficients, so 1, 3, negative 4, and negative 12. All All right, now we're going to pull down our 1, multiply around the corner. So negative 3 times 1 is negative 3. We're going to add down, which is 0. Negative 3 times 0 is 0. Add down again to negative 4. Negative 3 times negative 4 is positive 12. Add down, and we get a remainder of 0. So remember, whatever the last number is, that's your remainder. If it's 0, then that means that the number that we were looking at, negative 3, is a factor which is written as x plus 3. So this can now be written as x plus 3 times, and now the remainder part is the rest of the equation, what would have been left over when we pulled out x plus 3 from the original equation. And here's the thing, it started out as x to the third. When it pulls it down, it becomes x squared. So that is x squared, 1x squared, plus 0x plus the constant, so minus 4. And now we can try to see, well, can this new part be factored anymore? Well, we know that that's the difference of two squares. If we look at our reference chart, we know that it's x minus 2 and x plus 2. So those are all of the factors of the original equation. So at negative 3, at positive 2, and at negative 2, that function cross the x-axis. This one's a fully worked out problem again. It's a little bit more complicated because it ends up being a cubed after you do your synthetic division. You should always go one less. So if it starts at 4, after synthetic division, it's going to 3. If it starts at 2, after synthetic division, you'd be at 1, etc. And so when we would have to know a couple of different things, including how to use grouping, which we're going to get to that after Thanksgiving. So one more example, we're going to take x plus 4, solve for x, which is negative 4. That's what we're going to divide by, synthetically divide by. Then we're going to take 2, 8, 0, because we didn't have an x squared in the problem. There's no x squared. 2 and 8, and then we're going to follow the process. Drop down our 2, multiply, add, multiply, add, multiply, add, multiply, add, and we get 0. So that means that x plus 4 is a factor. So then to figure out the rest of it, we pull down what we have left. Well, we were at x to the third, fourth before, so now we're at x to the third. 2x to the third, nothing in x cubed, nothing, or x squared, x 0, x number. So x2, x to the third plus 2. They have a common factor of 2. We can pull that out. We end up with x cubed plus 1 using our reference chart. Anything to the third power plus something else to the third power will give us this function. So we have a 1 x to the third plus 1. 1 to the third power is still 1, so that means we can pull out an x plus 1, and we get x squared minus 1x plus 1, following the template. Again, that's following factoring, which we will do some more after Thanksgiving. Okay, so last kind of example, we can use this same concept if we're trying to find a second 0. So we know one of the zeros is 1. So we're going to use that one to reduce our x cubed down to an x squared type problem. And when we do that, we end up with 16x squared plus 16x minus 16. We pull out the 16 factor, and we end up with x squared plus x minus 1. Using quadratic formula, we can then figure out that we are approximately 6.618 positive. That's the positive number. I didn't do the minus because that would have been negative. And then taking 0.6 times 1,000, we can make 600 pieces of jewelry. So when you're doing the assignment, pay attention to what they're asking. If they say p of negative 3, that is literally just using synthetic division to plug it in, and we're looking for the remainder. You're looking for whatever's in that last spot, the remainder. Okay, that is where x is negative 3, what the y is. So p of P of -3, for another way of explaining that is your y. What is your y when it's at -3? X is -3. If it is asking for doing long division, do it long division. You should write your answer in the form of divisor, quotient plus remainder. So you should have it in the form of quotient, which is what you get on the top of the bar, plus your remainder, which is the remainder down here. And remember, remainder should be written as remainder over divisor to be completely accurate. Okay. For the questions that are doing synthetic division, you're going to first find your A, use your synthetic division, and obtain the quotient and the non-zero. So again, you're going to write your answer in the same form that you'd see here on long division. On these problems, you're actually going to determine if there is a factor and then the remaining factor. You can leave these in completely factored out. You can do it down to the first level. You don't